Hi everybody. I think I just got out my yawn, so hopefully I won't be doing that again. I'm going to give you a lesson on rational exponents. If you were able to print out the fill-in-the-blank notes that I put on Google Classroom, that's great. If not, you can go ahead in your notes and jot these down. I know we're doing things in such an unconventional way that if you want to follow along, you can do that too, because you can always refer to this. These are a little bit complicated. Oh, see, I yawned again. Oh, excuse me. But for the ones that have numbers on, you can use the calculator to solve them. I will tell you that. But it's important that you learn how to do it without the calculator as well, because that's how the variables are considered. So anyway, you have rational exponents for any real number b and any positive integer n. If you have something written b to the 1/nth, it's the same thing as the nth root of b. We've discussed that a little bit, especially with cubes, because some of you didn't have the cube root button available to you. Those graphing calculators don't have it. So I did have to explain the fractional notation. So anyway, 27 to the 1/3. If you were writing workout, you'd get the cube root of 27, which we know is 3. If you plug this into your calculator, you might use this button. If you plug this into your calculator, I don't know why, you would press, I think, would you press the 3 and then the 27, I think? You might have to mess with that order, but ultimately your answer is 3. For this one, you would press something like that. Or the X to the Y button, that's also another option. So writing these in radical form, I am so sorry. I'm trying not to distract you by yawning. I am beyond exhausted, but I hope you're all well. I really do. I miss you guys so much. Anyway, z to the 1/2 is equal to the square root of z. We don't often write that little 2. If you don't write it, that's even more ideal. Those two things are the same thing. And then you have z to the 1/9. That's the same thing as the 9th root of z. Writing it in exponential form, it's just the opposite. You have u to the 1/3. And this would be p to the 1/2. When you evaluate, like I said, don't be mad. I'm so distracted because I'm so tired. We have 81 to the negative 1/3. You can plug this into your calculator. When you're dealing with negative exponents, though, just remember it's the same thing as this. 81 to the 1 over 81 to the 1/3 on the bottom. Now, how could we evaluate that? Well, this isn't really ideal, because this is the same thing as the cube root of 81, which is not perfect. This is the same thing as 1 to the cube root 27, cube root of 3. See, evaluating this, I don't even know that I'm a big fan of the directions. And I probably did this last year and was like, why did I give this problem? So all the moves I'm making are legal. I know you like it when I use that expression. I moved it to the bottom. I wrote it in a form that I'm much more familiar with. That's a 3. I broke it into a perfect cube and it's leftover. And now I'm here. I know I can't leave it like that. So I have to consider, what can I multiply the top and the bottom by? Well, there's 1 3 inside this radicand. So that means I need 2 more 3's to make a collection of 3 3's. So your final solution is 3 times, that's the cube root of 27, which is another 3. That's your final answer. Yeah, the reason I'm not a fan of the word evaluate is evaluate usually indicates that it's going to be a nice answer. This one is not. But that's how you would simplify that problem. Evaluate it, you probably would plug it into a calculator. If you plug this into a calculator, I don't have one near me, my guess is you'd get a decimal. So we have 144 to the 1/2. Hopefully you can see that that is 12, because that's the square root of 144. Moving to the back side. Nothing is different about any of this. Except now I'm talking about there is a, here, let me go over here. B to the x over y. So now you have a numerator that is not 1. Has to be an integer, okay? Y has to be greater than 1. What happens is this still becomes whatever the root is, just like it did before. But now b to the x is on the inside of the radicand. And the other way you can write that is you can write it as b, and you can write it as all to the x. Okay? Except when b is less than 0 and y is even. Don't worry too much about those fine points. So kind of go all over the place in this because it's just a lot of information. When I'm asking you to simplify variables, well, what would you do if it were this? What would we do with that? That's right. I'm pretending like you're all answering right now. A to the 4th times a to the 3rd is a to the 7th. Same concept here. You have to add the exponents. So you would just get a to the 3/7 and call it a day. You wouldn't do anything else with that. Usually make my 7s with the little line. If we were to rewrite that as a radical, you would get the 7th root of a cubed. And c to the negative 1/3. You could never leave it like that. I know when I graded your quizzes, I tried to put comments. Wait, did I grade your quizzes? No, this was the review. No, I'm not even. Nope, I'm talking about a different quiz from a different class, the honors class. You can never leave a radical in the denominator, and that's what this says. Because this actually says that. Well, that's not legal to be left there. So there's 1c on the bottom. So to make a collection of 3 c's, you need to multiply it by 2 more. So the solution of this would be cube root of c squared all over a c. Because that's what this will become. Lastly, we're going to continue, not lastly, we've got two more problems to do here. These are always a little bit interesting. You probably will throw them into a calculator. But I'm going to still pretend like you're not going to. So this is 27 to the 1/4. I'm pausing so I don't yawn. That's equal to 3 to the 3rd to the 1/4. Which is equal to 3 multiply to the 3/4 over, what do I have there? 3 to the 1/2. So we subtract the exponents. 3/4 minus 2/4 is 1/4. There might be different ways to do that. I know sometimes the calculators do more than I really want them to do. But let me know if you have any questions about how I manipulated it. I'm not saying you can do it by yourself yet. I'm not saying I'm going to test you on it. I just want to know if you have questions about what I did. Or if I messed up. Oh my gosh, always tell me if I mess up. You know that though. And 4. How did I do this problem? This is 24. Why is it 24? Over 4 to the 3/2. Well, let's just do it out. That just says 24. 4 to the 3/2 is equal to the square root of 4. And I can write that 3 either right there, little baby 3, or I can go like this. It doesn't really matter. I think this is probably the easier way because I know that the square root of 4 is 2. So I just have to raise 2 to the 3rd. So I get 24 over 8, which equals 3. Hope you enjoyed it. I don't know how to turn this thing around so the spotlight's on me, so I'm just going to wave. Miss you guys.